important to remember that these triangles aren't going away. We're still going to need to know how to work with them. The 30, 60, 90, and the 45, 45, 90. And about 2/3, 3/4 of you have that down. But some of you don't still. And this is a thing we've been working on for 2 weeks. You have to have this memorized. The 45, 45, 90. The two legs are congruent. Hypotenuse is the leg times the square root of 2. For the 30, 60, 90, I'm going to draw it a little differently than I normally do, so you don't get hung up on just one picture. But now, my short leg is, my short side is over here. My hypotenuse is 2 times the short leg, and this is the short leg times the square root of 3. Thank you. Okay. So, make sure that you have these triangles memorized. They aren't going away. They're going to be on G3. You're going to need to know this stuff for the G3 quiz. That's part of our review section, actually, for the G3 quiz. Are going to be these triangles again, and identifying them and working with them and using that to set up ratios and proportions. Or actually just simple equations even to solve for unknown sides. We're going to still work with these triangles. They are not going away. The homework. Any questions on the homework? Yes, ma'am.
Number 9 is a special triangle.
Let me look at number 9. 477 was our page. Sorry, I closed my book. I didn't do my bookmark. Number 9 is a special. It's a 30, 60, 90. Yes, it is. Because it's 13, 26, and 13 root 3. It fits our pattern. Other questions? When we're doing problems like this, say, let's just pick number 10 because it's all set up for, the picture's drawn the right way for number 10 and everything. We had X, Y, 32, and 18. Just kind of reviewing what we're doing here. One of the best ways to set these things up, we talked about the targeted approach versus the shotgun approach a little bit on Friday. Generally, when I do these, I just throw shotgun out there because it tends to be faster. It tends to be a little bit quicker just to see what happens. Throw all 3 equations out. If I just have one variable that I'm solving for, I only need one equation. I'm not going to break 3 equations to try to solve one. Then I'll really focus in on which one to use. But when I'm solving for 2 variables, generally I'll just go ahead and throw all 3 equations out there and see what works. So again, we get our perspective. So we're at. We identify our sides. Which side is the opposite? X is the opposite. Which side is the hypotenuse? So for this angle, the adjacent would have to be Y. Once I have that, I also write down my secret phrase. SOHCAHTOA, which stands for sine opposite over hypotenuse, cosine adjacent hypotenuse, tangent opposite adjacent. I jot that down just for remembering what's what. And I just set up my 3 equations. I'm going to say, okay, what's the sine of 32? The cosine of 32, and the tangent of 32 for the ratios we have here. All right, sine of 32 has to be the opposite over the hypotenuse. So the opposite is x, the hypotenuse is 18. There's my equation. Cosine of 32 has to be the adjacent over the hypotenuse. Tangent of 32 is the opposite over the adjacent. Oh, that one has 2 variables. I cannot solve that. But the other 2 I can. Remember, we aren't going to get both x and y by doing just one equation. We're going to need 2 completely separate equations for that. And we have it. And how do we solve this? Well, it's simple. We multiply both sides by 18. Actually, both times we wind up doing the same thing. So x is 18 times sine 32. Y is 18 times cosine 32. Then it's just a matter of plugging that into my calculator. 18 sine 32. Ooh. 18 sine 32 is 9.53. So that's x. 18 cos 32 is 15.3. Now, the last thing we want to ask ourselves is, do those answers make sense? I didn't wind up somehow with the hypotenuse being shorter than one of the sides, did I? No. And the smallest side is opposite my smallest angle, the middle side opposite the middle angle. Because this is 32, this has to be 58. Yeah, it all makes sense. It all fits together. And that's how we solve something like that. We have to be able to identify our sides and know our ratios and set up our equations. So when you're doing a problem like this, I want to definitely see all of this. Don't just write x equals, oh, I did, and then say, oh, I did it all in my calculator. Granted, 18 times sine 32 you probably did in your calculator. That's the appropriate way to handle it. But I want to see how you got there. I want to see the equation you used to set that up and show your work. That's how you got there. Don't just be all like, I got way too many people who have been trying to shortcut things this year, and I'm just going to do it in my head, and so I can just put it in my calculator and go, and I don't have to write anything down. It always leads to problems. Don't do that. Write it down. Other questions? Let's look at this problem for a second. If this showed up on a standardized test, like the plan test, which you're taking less than a month from now right now. Most of you are sophomores, you'd be taking the plan test. And if you're freshmen in here, you might be taking the plan test anyway. Okay? If you're not taking the plan test, you're probably taking the explore test. So it's just a test. Yeah. If you're a junior or senior, you take the ACT. Or retired ACT. So, okay? But this is a typical type of question. How are you going to go after something like this? It says, which can be used to find PQ? What do you think? B, okay? Well, let's see if we can find out. PQ is right here. So let's go ahead and just call that N for now. Okay, so I can work with this. How would I set up the equation? Here's my angle. Or we could actually turn the P into maybe the little person down here. So, there we go. Okay. Here's my angle. Which side is 10? This is the opposite. And the side we're looking for, N there, is the hypotenuse. Which function uses opposite and hypotenuse? Sine. Okay, so cosine is out, isn't it? Process of elimination. Now I'm going to 10 times cosine 29 or 10 divided by cosine 29. Well, you know what? We could set up the equation, solve it, or we could put those in our calculator. Okay? If I do 10 times sine 29, 10 times sine 29, that would give me 4.84 for this length. Would that make any sense whatsoever? Could this side be 4 if this leg is 10? Why not? Hypotenuse must be the longest side. So how about 10 divided by sine 29? It gives me 20.62. Does that make more sense? Sure does. So B is ruled out just because it's an impossible answer. The answer must be C. We have to use sine, and B doesn't work. It gives me a nonsense answer. So without even having to set everything up, I can solve that. But let's go ahead and set it up anyway, just for the sake of doing so, because there's a technique here that we do need to review. If I set it up, sine of 29 equals opposite over hypotenuse 10 over n. And that's where the variable's in the denominator. And as we talked about on Friday, if my variable is stuck in the denominator, we just simply take these two items and we swap them. Now, there's a whole algebra reason why that works. You don't need to know the reason why, you just need to know that it works. We swap them both, so n is 10 over sine of 29. Remembering that sine of 29 has its own value. And there it is. So even equation-wise, it's not that hard to work with, but remembering what to do when the variable's in the denominator, that's something people struggle with a little bit. Some of your homework tonight is going to look like this. Solve the triangle and then convert the sine, cosine, and tangent of angle A into 4 decimal places. And this is kind of setting us up for what we're going to be doing more tomorrow, these problems are. So it's not real hard, but it's heading us in a direction we want to go. First, I have to find this third side of the triangle. How am I going to do that? I know 2 legs. I need to find the hypotenuse. How can I do that? What tool do you have in your toolbox that can handle that one? Which one? Sine, cosine, and tangent aren't going to help me here because I don't know any angles. Except the right angle. How, if I know 2 sides of a right triangle, do I find the third side? Yes. Yes. Pythagorean theorem. Yeah. You're overthinking it, aren't you? You're thinking something really, really hard. What weird Pythagorean theorem? Don't forget about the obvious, okay? 7 squared plus 18 squared equals c squared, because I'm looking for the unknown side here. So that's 49 plus 324 is 324. 373 is c squared, so c is the square root of 373. That's fine. I don't need to simplify that or do anything with it. In fact, because we're just decimalizing, I can go ahead and set these up fairly easy. Sine of A will be what ratio? Angle A. Which side is the opposite? This is the hypotenuse, which means this must be the adjacent. So sine of A is opposite over hypotenuse, or 7 over the square root of 373, which since I'm just decimalizing, I'm not going to worry about rationalizing. We're going to take 7 divided by square root of 373. Your calculator will handle that just fine, 0.3624. So cosine of A is 18 over root 373. Or 0.9320. And the tangent, which is opposite over adjacent, would be 7 over 18. Which is, again, approximately 0.3889. So for a bunch of the first set of problems today, that's really all you're doing. Getting them as ratios and then converting that ratio to a decimal, because we're going to use that tomorrow then to work backwards to help find the angle for angle A. You're going to see how that's going to work. The other thing we're going to do today is story problems. You're like, oh, no, not story problems. They're really not that bad. Because guess what? Every story problem is going to require us to set up a right triangle. That shouldn't be a shock. Now, a couple of phrases we need to be comfortable with. Angle of elevation and angle of depression. An angle of elevation or an angle of depression is always taken from your line of sight horizontal. So straight out from your eye. An angle of elevation is looking up. An angle of depression looks down. All right? That's the way it works. That's the way we measure an angle of elevation or depression. Now, this is something that's done a lot in things like navigation. But it's also used in surveying and stuff like that. And so it works. This is actually a very real-world type of application in travels. So, let's say you're looking at a mountain that you know is 12,000 feet tall. You're at the elevation of 4,000 feet. Your GPS tells you that. When you look at the peak, you calculate the angle of elevation to be 9 degrees. How far would it be if we were to drive right underneath the peak? How far would this distance be? Well, I've drawn the triangle already for this problem. Angle of elevation from the horizontal looking up is 9 degrees. We were at 12,000 feet for the peak, and we're at 4,000 feet right now, so that difference of this side here is 8,000 feet. That's where the 8,000 is coming from. 12,000 minus 4,000. There's only 8,000 feet of elevation difference. If this is 9 degrees, which side is this? Opposite, adjacent, or hypotenuse? The 8,000. Opposite. And x is the adjacent. Which function are we going to use to solve for this? Which function uses opposite and adjacent? Tangent. Tangent of 9 degrees is the opposite over the adjacent. Oh dear, x is in the denominator. What will I do? Swap them. So x equals 8,000 divided by tangent of 9. And now, that's easy. I just put that in my calculator. This is about 50,510 feet. Or about 9 miles. 9 to 10 miles away. Okay? So these are the types of problems you're going to see today. You're going to see problems like this. Got a couple more examples for you. A pilot spots the airport runway at an angle of depression of 3 degrees. The altitude of the plane is 32,000 feet. The elevation is 500 of the runway is 500 feet. It's probably a good idea if you're trying to land a plane that you know the elevation of your runway. All runways are not at 0 feet. It would be very bad if your runway is at 0 feet and it's actually at 500 feet because you're going to be on the ground 500 feet sooner than you thought you were going to be. That's called crashing. If you're going to fly an airplane, this is important. Now, here's the problem people make. They go, oh, 32,000 feet, so this is 32,000. Nope. The height of the airplane's at 32,000. Height of the runway is at 500. The actual distance here is 31,500. Now, what a lot of people do is they'll draw their triangle this way. Okay? And they'll put their 3 degrees right here. That's incorrect. Why? Yeah, the angle of elevation depression always has to be taken from the horizontal, right? The 3 degrees is actually here from the horizontal, not from the vertical, which means this angle is actually what? 87 degrees, right? Complementary. Oh, okay. Now I can figure that out. How far away is this point from here? Now I've got my angle, I've got my picture all drawn. X is which side? According to this angle here? the opposite. 31,500 is that's tangent again. Tangent of 87 is x over 31,500. How do we solve that one? Yep. So 31,500, ooh, that's not right, times tangent of 87, it's going to be 601,055 feet. Now, if they're 5,280 feet per mile, just for reference, it's about 113 miles. About 113 miles to the airport. Now, if instead it asked for what's called the glide path of the airplane, then my x would have moved up here to the hypotenuse. This would be what they call the glide path to the airport. But as you can see, these problems are about setting up, using the written description to set up and solve a triangle. You'll need to draw a picture. You want to find the height of a tree. You look to the top of the tree at an angle of elevation of 71 degrees. You're 20 feet from the base of the tree. How tall is the tree? This is a real problem that I've actually done. Not the exact measurements, but I've done this problem. I've been sitting at a friend's house and been going, gosh, we want to cut down this tree. It's kind of half dead. But I need to know if I got enough space to drop the tree or if it's going to hit the house. Do we need to call somebody in to do it, or can we just drop it ourselves? That's kind of important to know. You don't want the tree falling down and hitting the house or the garage or whatever is there. Okay? Well, this one was going to be close. So what we did is we actually measured that angle of elevation and used trig to find the tree to see if it would fit in the space or not. It would. We had about 8-10 feet of clearance, which is good because when the tree hits the ground, of course, pieces fly. You don't want to break windows, shatter windows or something when things fly. Covered up a couple windows just to be safe. All right? But again, here you are, angle of elevation at the top of the tree, height of the tree. It says the angle of elevation, which has to be taken from the horizontal, is 71 degrees. I am 20 feet from the base of the tree. I need to know the height of the tree. What function am I going to use for this? Tangent again. So tangent of 71 is the height over 20. So 20 times tan 71 is the height. And again, we just put that in our calculator. So about 58.1 feet. So if I have 60 feet of clearance, I'm probably okay. It's going to be tight at 60 feet. 70 feet, I'm pretty comfortable. But this stuff is doable. I mean, it's really stuff that you can do. You got a question? It was one of those trees that had a lot of the branches are on one side, so it was gonna go that way. It was kind of leaning, and if it's leaning, gravity is gonna beat the notch. If the tree is leaning and heavy one direction, you can notch it the other way if you want. It's not gonna beat gravity and come over the top of its center of gravity. This is just going to work best this way, safest. You're much more likely to if you notch the opposite way for it to twist. And twisting is bad. You want to work with gravity, not against it. And if you really want to do it against gravity, you can attach cables to it and pull it the other way too. You know. Smash the window out of your truck doing that, you said? Well, there you go. So again, setting up and working with the trig formula. What's our phrase? So katoa, right? This is going to take some practice. A lot of you didn't do the homework over the weekend. You need to be doing this homework. You're not going to get this by just listening to me. You've got to practice it yourself. You've absolutely got to. Tomorrow we're going to take it, like I said, to the next level, and we're going to go back and look at something like this. Okay, now that we know these values, how do we use that to find the measure of the angle? That's the last new thing we have to learn. Now, once we have those values, can we find the angle? And the answer is yes. Doing so is not difficult. We got to know how to set it up correctly. It's all about getting it set up. Your assignments. Here we go, 22 through 29, 33, 34, and 42. It's not a huge assignment. Today is the 10th. We're over a third of the way through February already. March is just around the corner.